welcome to this deep dive. And today we're diving into the Diabolical Cube.
Oh, a classic.
Yeah, a puzzle that I think is going to really make you think, especially, I think, given your STEM background.
Yeah.
This is going to be right up your alley.
Absolutely. It's a fascinating puzzle, and what's really interesting is that it has a really rich history.
Oh, wow.
You might be surprised to know that the Diabolical Cube could actually be the oldest known puzzle of its kind. Yeah, predating even the famous Soma Cube.
Wow, so older than the Soma Cube.
Yeah, and so with its 6 uniquely shaped pieces, it's been puzzling people for quite a while.
I mean, it's amazing how something so simple looking can have such a long history.
Right.
So let's talk about these 6 pieces we're dealing with, polycubes, is that right?
That's right. Polycubes are shapes made by joining cubes together.
Okay, so like building blocks, basically.
Exactly, and we have a range of them in this puzzle.
Okay.
We've got a dicube, which is formed from 2 cubes,
Okay.
to tricube with 3,
3.
and so on all the way up to a heptacube
7.
with 7 cubes.
Okay, so we've got all these different shapes.
Yeah.
And the challenge is to fit them together, is that right?
Yes, the challenge is to fit these 6 polycubes together to form a perfect 3 by 3 by 3 cube.
Wow. So it's like we're talking 3D Tetris here.
Yeah, that's a great analogy.
Yeah.
Understanding the shapes and how they fit together.
But a lot more complex.
Yeah, definitely.
Now, something I noticed about these pieces is that they all seem to have a single layer of cubes. Is that right?
That's right. All the polycubes in the Diabolical Cube have a single layer of cubes.
And is there a reason for that?
Well, it's not just an aesthetic choice.
No.
It actually has a significant impact on the number of possible solutions.
Oh, really? How so?
Because these polycubes have a single layer, they're unchanged when reflected in a mirror.
Okay, I'm trying to visualize this.
So for every solution you find, its mirror image is also a valid solution.
Okay, so that doubles the number of solutions.
Exactly. It adds a whole other layer of complexity.
So how many solutions are there total?
For the Diabolical Cube, there are 13 distinct solutions excluding mirror images.
13, that's a lot.
Yeah. It's remarkable how a seemingly straightforward puzzle can have so many solutions.
So how do they figure out that number? Is it just trial and error?
No, definitely not. It's much more systematic than that.
Okay.
It involves a field called computational geometry,
Oh, wow.
and algorithms specifically designed to solve these kinds of spatial problems.
So they use computers to help solve these.
Yeah, essentially imagine a computer program that can analyze all the shapes of the pieces and all the possible ways they could fit together.
That makes sense.
Taking into account rotations and the constraints of the 3 by 3 by 3 cube, these algorithms can map out the entire solution space and identify all the distinct solutions.
So it's not just about spatial reasoning, it's about understanding algorithms too.
Right. It's a really cool intersection of math and computer science.
And it's all because of this one puzzle.
The Diabolical Cube is full of surprises.
So are there other puzzles like this that maybe our listener might be familiar with?
Yeah, there are a few others that are similar. You might have heard of the Soma Cube.
Okay, yeah, I've heard of that one.
That one's constructed from 7 pieces, all polycubes with 4 or fewer cubes.
Oh, wow. So even more pieces.
Yeah, and it has a surprising number of solutions, over 240, excluding rotations and reflections.
240, wow.
Yeah. And another one is the Slothalber-Gratzma puzzle.
Okay, I've not heard of that one.
It uses 9 pieces to form that same 3 by 3 by 3 cube.
Okay, so the Diabolical Cube is kind of in between in terms of number of pieces.
Yeah, you could say that.
But it sounds like each puzzle has its own unique challenges.
Absolutely. The number of pieces and their shapes really impact how difficult the puzzle is.
And how many solutions it has.
Exactly.
It's like a whole world of spatial challenges out there.
It really is. And you know what's really fascinating about the Diabolical Cube?
What's that?
Is that its connection to computational geometry hints at its potential applications, beyond just recreation.
Oh, really? Like what?
Well, think about it. The ability to analyze these spatial arrangements and find solutions,
Yeah.
it could be valuable in a bunch of different fields.
Like what kind of fields?
Well, you've got fields like computer graphics, for one,
Okay.
robotics, even protein folding in biology.
Oh, wow. I wouldn't have thought of that.
Yeah, they all involve understanding complex shapes and how they interact in 3 dimensions.
So you're saying the algorithms they use to solve this puzzle
Right.
could be used for more than just games.
Exactly. The fundamental principles are the same. Analyzing shapes, identifying patterns.
Setting solutions.
Right, within a given set of constraints.
So even though it seems abstract,
Yeah,
there could be real-world applications.
absolutely. It shows how interconnected different areas of study can be.
It really is amazing. Who would have thought a simple puzzle
Right.
could offer insights into complex scientific problems.
Yeah. It's a perfect example of how you can start with a simple observation.
The puzzle.
Exactly. And then delve deeper, uncovering patterns and principles.
And make connections.
Right.
That's pretty cool.
It really is like a microcosm of the scientific process itself.
Oh, I like that.
And of course, it's a fun challenge, too.
Yeah, definitely.
It's no wonder people have been fascinated by these puzzles for centuries.
I can definitely see the appeal.
There's something inherently satisfying about taking these separate pieces and then fitting them together into a perfect whole.
It's a good feeling.
Yeah, it's like order emerging from chaos.
And that feeling is probably what keeps bringing people back for more.
Oh, absolutely. It's a reward in itself.
Right.
But it's not just about the gratification. These puzzles actually help you develop valuable skills.
Like what?
Well, things like spatial reasoning, problem solving, abstract thinking.
Skills that are useful even outside of STEM.
Exactly. No matter what you do, these skills can come in handy.
So for our listener who's probably intrigued by all this, how would you recommend they approach the diabolical cube?
Well, I'd say don't let the name intimidate you.
Yeah, diabolical cube does sound a little scary.
Right. Just start by familiarizing yourself with their shapes, how they relate to each other. Maybe try sketching them out or visualizing them in your mind.
That's a good tip.
And remember, there's no one right way to solve it.
Right. We talked about those 13 solutions.
Exactly. It's all about finding a solution that works for you.
Maybe our listener will even discover a new approach.
Wouldn't that be something?
Yeah.
We've covered a lot of ground today, from the history and the mechanics of the cube.
To its connections to science and problem solving.
Right before we wrap up, any final thoughts?
I think the diabolical cube is a great example of how a simple object can be so complex and so fascinating.
Yeah, well said. It really shows the power of curiosity and the joy of exploration.
Exactly.
And who knows what other hidden complexities are waiting to be discovered in its simple structure.
Yeah, it really makes you think, doesn't it?
It does. And it's a reminder that intellectual curiosity can lead to some pretty amazing discoveries.
Absolutely. So as we wrap up here, any last tips for our listener who's ready to tackle this diabolical cube?
I'd say approach it with a sense of playfulness and curiosity.
Okay.
Don't worry too much about finding the right solution. Just enjoy experimenting with the pieces, visualize them, see what you can come up with.
I like that. Just play around with it.
Exactly. You might even find a new approach or a variation that nobody's thought of before.
Yeah. Maybe our listener will discover something new.
You never know.
Well, that's a great note to end on, the possibility of new discoveries hidden within this seemingly simple puzzle.
Absolutely. It's been great talking about this.
Yeah, this was a fun one.
It really was.
And for our listener out there, happy solving.
Good luck.